Hello, class. We're going to talk about forces and basically Newton's second law and third law, basically. Now, to reiterate, Newton's second law is the net force that we're going to look for is the sum of all the mass and all the forces together, and that's equal to the mass times the net acceleration in the direction the force is being applied. And then Newton's second law states that the acceleration of an object is directly proportional to the net force acting on the object, and it's inversely proportional to the object's mass. So it's kind of putting those together. We talked about this a lot. Now we're going to end up looking at how to solve problems using the Newton's first, second, and third laws. So the equation's simple. Mass is equal to ma. Now we're going to look at net force. So we add up all the forces together and we end up with a net force. And this is gotta be careful because net means the final force or the sum of the forces. Sometimes we'll give you the net force. Sometimes you need to find that net force, and it's all depending on what the question is asking. So let's go to the first example. So in this example, we have a house, and basically we're telling you what we're doing with this house. It's being lifted up onto a truck. And so that's the background. The house is being pulled over by a net force. So here's our, now this is important. The net force is this, 2,850 newtons. And now, while this force is being applied, the house is moving from rest to an upward speed of 15 centimeters per second in 5 seconds. We want to know the mass of the house. So let's do some things. Let's say we have a force, and that is going to be 2850. That's our force. The mass, we don't know. Acceleration, we don't know yet, but we have an initial velocity of 0 and a final velocity of, and I believe that is 15 centimeters per second. And we have a time of, and I believe that's 5 seconds, yes. So let's do a couple things. First, let's go ahead and convert that to meters per second. So 15 centimeters per second. And you should know how to do this already, but for 100 centimeters, we have 1 meter. That gives me a value of 0.15 meters per second, and that's going to be my final velocity. So this is going to be 0.15 meters per second. Now, force is what we have, and we're looking for mass and acceleration. We don't have an acceleration here, but remember that acceleration is equal to the change in velocity over the change in time. We know the change in time is 5 seconds. Our change in velocity is going to be 0.15 meters per second, so our acceleration is going to be 0.15 meters over 5 seconds, 0.0 seconds. And that's going to give us a value of, I want to double check my math, 0.03 meters per second squared. And so that's my acceleration. So if we take the force, divide by acceleration, we're going to get our mass. So plug in the numbers, 2850 divided by the acceleration in meters per second, that's 0.03. We should have the mass. So 2850 divided by 0.03, and we're going to get a mass of 95,000 kilograms, which kind of makes sense for the mass of the house. And if we look at the units, newtons is going to be kilograms, meters per second squared, divide by meters per second squared. These cancel and end up with kilograms left. So this is my answer. We didn't have to do anything fancy. We didn't have to dissect gravity or anything else because we were given the net force. And we're looking And we were able to determine the net acceleration just by velocity, by taking the difference in velocity divided by time. And from there, we figure out the mass. And there we go, folks. If you have any questions, let me know. See me at Scott Time or after school. Bye.